Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today, we want to present about Maxwell bridge. Firstly, I want to present myself and my group members. My name is ASLAM bin Muhammad BAKAR. My group member is Cik Muhammad AMIR, Muhammad SAYUTI and AMIRUL. For the introduction of Maxwell bridge, the bridge used for the measurement of self-inductance of the circuit is known as the Maxwell bridge or Maxwell inductance capacitance bridge. It is the advanced form of the Wheatstone bridge. The Maxwell bridge works on the principle of the comparison, that is the value of unknown inductance is determined by comparing it with the known value or standard value. The purpose of Maxwell bridge is used to measure an unknown inductance, usually of low Q value, in terms of calibrate resistance and inductance or resistance and capacitance. Types of Maxwell bridge. Maxwell bridge has two methods are used for determining the self-inductance of the circuit. They are Maxwell's inductance bridge, second Maxwell inductance capacitance bridge. Next, I want to present component in each branch of Maxwell bridge. For the component is branch A and C is no standard resistance. For the branch B and D, a no variable resistance. This is variable. For the branch A to B is no capacitance in parallel with a no resistor parallel. For the branch C to D is unknown resistance in series with unknown inductor. And lastly is branch B to C and AC null detector to detect balance condition.
My name is Cik Muhammad AMIRSYAD bin Cik AMRAN. I will continue to present the configuration of Maxwell bridge. In such type of bridge, the value of unknown resistance is determined by comparing it with the known value of standard self-inductance. The connection diagram for the balanced Maxwell bridge is shown in figure below. This is the figure for balanced Maxwell bridge. Let L1, here is L1, unknown inductance of resistance R1. L2, here L2 is variable inductance of fixed resistance R1. R2, here is R2, variable resistance connect in series with inductor L2. For R3 and R4 is non-inductance resistance. At balance Maxwell bridge, here is the formula for L1 and R1. For L1 is R3 over R4 times L2. R3, R4, and L2. For R1, the formula is R3 over R4 times R2 plus R2 here, the variable resistance. The value of R3 and R4 resistance varies from 10 to 1000 ohms with the help of resistance box. Sometimes for balancing the bridge, the additional resistance is also inserted into the circuit. Here is the calculation for balanced Maxwell bridge. Maxwell bridge is used to measure an inductive impedance. The bridge constant at balance are, this is the example, the value for this Maxwell bridge. The inductor is 0.01 microfarad, R1 is 470 kilo ohms, R2 is 5.1 kilo ohms, R3 is 100 kilo ohms, R3. How to find the series equivalent of the unknown impedance is, here the solution is, first we need to find the Rx and Lx. For Rx is R2 times R3, R2 times R3 over R1. 100 kilo times 5.1 kilo over 470 kilo ohms. The value is 1.09 kilo ohms. Next, Lx is R2 times R3 times C1. R2, R3, and C1 here. The value is 5.1 Henry. Then we calculate the Lx. 2 pi times frequency times inductance. 2 pi times 60 times 5.1. The answer is 1922.65. Then we calculate the Zx. The unknown impedance is Zx. Rx plus JSL. This is the value. So we can calculate it with calculator. This is the final answer.
Okay, my name is Muhammad SYUWARI bin SHAFII and I will continue at simulation part. Okay, first we construct the circuit. Okay, this is the circuit of Maxwell bridge. Refer to the diagram in the calculation. Okay. What we want to do is we need to find the value of voltage, current, and impedance. First, we see at the value of voltage. Okay. Before that, I want to make it easy. I label it. This is at point A, and this is point B, and at this point B. Sorry for bad handwriting, and this for point C. Okay. As we can see, the value of voltage at AB is equal to AC, which is 94.45 volt and 94.39 volts. And the value at voltage DB and DC is equal also. Why this voltage is equal? This is because this bridge is at balance condition, which is why I said this is in balance condition, which is the value at the middle of the bridge is 65.62 millivolt. That means the value of volt is near to the zero. When we change the value of 65.62 millivolt, we can get 0.06 volt. That's near to the zero. Okay, next we go to the value of current. First, I label it first. Okay, this A, this is point D, and this is point B, and this is point C. Okay, as we can see, the value of at the left side is equal. Why the value is equal? This is because we refer to Ohm's law, which is when the current is in series, the value will equal. Okay, and the value for that is 409.91 microampere, and for the right side is 18.51 milliampere. Okay, next we go to the output waveform, and this is the result of output waveform when the in the balance condition. And this is the value that I have got, the value of impedance. We have see at the 60 Hz, which is the impedance of Z is 2213.8. Okay, that's for the balance condition. And next I will pass to my friend AMIRUL to explain about what will happen when 2% increment is increased at the ZX arm. Okay, that's all for me. Thank you.
My name is AMIRUL SAMSOL, and today I'm gonna present about what happened to the voltage and current after 2% of increment. As we can see, before the increment of 2%, the voltage as shown by measuring by the multisim, you can see 41.006 for the circuit in the variable resistor and variable inductor. In this bridge, we using the variable resistor and the variable inductor to cut the voltage and current. So by using this component, we can adjust the increment. So after the 2% of increment, we can see the voltage has been increased by several decimal. So we proceed to the next for the current. The current we can see, so we can see by putting the multisim in the circuit, you can see the current 18.508 microampere, milliampere and 18.508. The same because it's a series, and the series the current are the same. So what happened after the increment? It increased to 18.325 milliampere. So why the current and the voltage increase after the 2% of increment? This is because the flow of the current, the flow of the voltage has been more to the circuit by through the inductor and resistor. So the more current flow, so the voltage and the current will
increased. For the discussion and conclusion, the value of theory was matched with the simulation on multisim. After constructing the experiment, it showed how to measure unknown resistance value in a laboratory setting. It explained how to build up a Maxwell bridge and how to manipulate one. In addition, the lab demonstrated the previously indicated linear connection. Given the fact that there was a significant inaccuracy in this lab, the result properly illustrates the connection directing the Maxwell bridge for understanding in an experimental context. That's all from us. Thank you. Settle.
Settle.
Dah dah.
Boleh, boleh.
Jadi
Sedap
ya ni,
juga,
jadi ya kita ni.
Jadi ya.
Jadi aku.